Hello and welcome to lesson 3 of week 1. In this lesson, we are going to look at the bubble sort algorithm. My name is Mildred. Now, the bubble sort algorithm is such that it loops through all the items in the arrays, and while it loops through, it compares each item to the next. If it is larger, it swaps until it gets to the end and takes the largest item to the end and starts all over until the array is completely sorted. So when we have n number of items in the array, it's going to loop through n times. So we'll have n times n number of iterations. We want to write an algorithm that will help us implement the bubble sort in Python. We know that the definition of bubble sort is to take the first value, compare with the next. If it's larger than the next, it swaps them and compares to the next, swaps until it gets to the end, drops the highest there, start from the beginning again. We want to create an algorithm to do this. So first of all, we want to say go through the array one at a time. Then the next step we want to use is to make sure that the array is not already sorted. And how do we make sure this is not already sorted? It means that we might have an outer loop that goes through the array, and we'll have an inner loop that checks if it's already sorted and continues the loop or something like that. And then we have for each values now in the inner loop, for each value, compare with the next and swap if higher than the next. Okay, and then the next thing we want to do is repeat until completely sorted. This is what we want to do. So let's create a function that will help us achieve this. So let's have def bubble sort, and we want to pass in some array here. We want to say that we want to loop through the number of items in the array, right? So we want to say n will not be equal to, let's get the length of the array. When we get the length of the array, it's always one more than the last index position, and so we want to say for I in range. So range now will be n minus 1 because we want to have the last index position. So for I in range, it starts from 0 to n minus 1. All right, so for I in range n minus 1, we want to have an inner loop that will avoid going out of bounds, right? And also that will check the number of elements that has already been sorted. And so we'll do that for j in range. So to get the already sorted one will be n, the total item n minus 1. Then we're going to subtract I, which is the already sorted one part, right? And then we're going to say if the item held in the current iteration, the current index position, is greater than the next. So if array j is greater than array j plus 1, we want to do something. We want to swap them, right? So we'll say array j will now be equal to array j plus 1, and array j plus 1 is equal to array j. So we can do this on one line to say array j plus 1 is equal to array j plus 1 array j, like this. So we're swapping here, and after the swap we want to return the sorted array because this loop will continue until it is done, and so at the end of the day we want to return the sorted array. So let's test this to see. If we want to say, so we have the array numbers here, we want to use bubble sort. Let me put some values that are here. So we want to say print bubble sort, and we'll pass in these array numbers, and let's see this. So we have it sorted from lowest to highest, and so we see how the bubble sort is implemented and the logic of writing an algorithm to think about how to do this. But we know that this bubble sort always loops through every value in the array, and whenever it reaches the end of the array, it drops the higher value, starts all over, drops the higher value. And so the larger this gets, the more time it takes. So we have n times, right? So in worst case, we're going to have n square. So the worst case time complexity for the bubble sort is n square. The best case is when it's already sorted and is n, but we're looking at the worst case when we're trying to look at the best sorting algorithm. We are going to look at other sorting algorithm in next week's lesson, and then we're going to compare the worst case scenario and see which sorting algorithm is the best or has the best worst case scenario. Thank you, and see you next week.